Welcome to online classes. Dear student, good morning.
Chapter 11 Force and Pressure. Concept of force. For example, kicking a football, beating a drum, etc. We have to act in many ways. Throwing a ball, push. Kicking a football, push. Pressing, plasticine, change in shape. Effects of force. Force can cause motion in a stationary body, body at rest. A book is lying on a table. If we apply a force of push or pull, it starts moving. Similarly, a football lying on the ground when kicked begins to move. Similarly, we apply force to push a chair, move a toy car or move a bicycle. We can say force can cause motion in a stationary body, body at rest. However, it is not necessary that a force always makes a stationary body move. Force can stop a moving body. If we apply brakes to a moving bicycle, it stops. Force can change the direction of motion of the moving body. When we play badminton, we change the direction of the shuttle by applying force in the opposite direction with the help of a racket. Force can change the speed of a moving body. If a person pushes a moving swing, it will move faster, and if he pulls the swing in the opposite direction, it will slow down. Force can change the shape and size of a body. We have seen that on stretching a spring or a rubber band, its length increases and its shape and size change. Classification of force. Force may be classified into the following two classes: contact forces, non-contact forces. Contact forces, a person pulling a coiled spring. Contact forces are forces which act only when objects are in physical contact with each other and bring about changes. A person pulling a cart. Some important contact forces are muscular force, mechanical force, frictional force. Muscular force. This force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular force. A boy uses muscular force to lift a bucket. A boy uses muscular force to kick a football. A girl uses muscular force to pedal the cycle. An elephant carries load. Oxen plow our fields. A camel carrying a person. Horse pulling a cart. Mechanical force. A car can move only when its wheels are made to move. The force exerted by the car engine to move the wheels is the mechanical force. A car engine burns petrol or diesel or CNG to generate mechanical force. Sailboats use the energy of wind to produce mechanical force, which propels the boats. Windmill also uses the energy of wind to produce mechanical force, which rotates the blades of the windmill. Windmill also uses the energy of wind to produce mechanical force, which rotates the blades of the windmill, which run the electric generators to produce electricity. A sailboat, windmill. Frictional force or friction. A ball rolling along the ground gradually slows down and finally comes to rest. We find no visible force appears to be acting on the ball, yet its speed gradually decreases and finally it comes to rest after some time. Friction. The force of friction between the surface of the ball and the ground that opposes the motion of the ball brings the moving ball to rest. Force. Force. Force of friction. Non-contact forces or action at a distance force. Some forces do not involve physical contact between two bodies on which they act. They act through the space between them. Such forces are called non-contact forces. So, non-contact forces are forces which can act even when objects are not in physical contact with each other and bring about changes. Some important non-contact forces are magnetic force, electrostatic force, gravitational force. Magnetic force. A magnet exerts a force or pull on an iron clip even when they are not in contact. So, the magnetic force is an example of non-contact force. Electrostatic force. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. Tiny pieces of paper were attracted by the charged comb. It indicated that electrostatic force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of non-contact force. A plastic comb rubbed in the hair. Charged comb attracts small pieces of paper. Electrostatic force. Gravitational force. Every object in this universe attracts every other object with a certain force. Boy, tree, force of attraction, force of gravitation. Pressure. Pressure is produced when a force acts on an object. If we push our thumb hard on a piece of wood, the thumb does not go into the wood. But if we push a drawing pin into the wood with the same force of our thumb, the drawing pin goes into the wood. Although the force applied on the wood is almost the same in both the cases, the drawing pin has a much smaller area of contact as compared to our thumb. This means that in the case of the drawing pin, the area over which the force acts is smaller and therefore its effect on the wood is much greater. It goes into the wood. This is because of a physical quantity called pressure. The drawing pin goes into the wood due to the sharp tip. The force of thumb falls on a very small area of the wood, due to which force per unit area or pressure on the wood becomes very large. Thus, the effect of a force depends on the area of the object on which it acts. Applications of pressure. A heavy truck is fitted with 6 to 8 wheels. These wheels increase the area of contact on which their weight acts and hence reduce their pressure on the ground. Skiers use long, flat skis to slide over snow. The larger the area of contact, the lesser is the pressure on the snow, enabling the skier to slide over the snow without sinking in the snow. The cutting edge of knives, blades, axes, etc. are sharpened. As the cutting edge is sharpened, the area of contact decreases, and hence pressure exerted by them increases. Foundations of high-rise buildings are kept wide so that they exert less pressure on the ground and do not sink in due to the extremely high pressure of the building. The tip of a sewing needle is sharp and pointed. This may put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. A school bag has wide straps made of thick cloth, canvas, so that the weight of the bag may fall over a large area of the shoulder of the child, producing less pressure on the shoulder, making it more comfortable to carry the heavy school bag. A wide steel belt is provided over the wheels of army tanks so that they exert less pressure on the ground and do not sink into it. Pressure exerted by liquids. All the liquids have weight, so when we pour a liquid into a vessel, the weight of liquid contained in the vessel exerts pressure on its walls and bottom. Let us perform the following activities to know more about liquid pressure. Applications of liquid pressure. The wall of a dam is made thicker at the bottom. Since water pressure increases with depth, the wall of a dam is made thicker at the bottom. A thicker wall can withstand a greater pressure exerted by the water at greater depth. Water supply tank is placed at a high place in the building. The water supply tanks are placed generally on the terrace, on top of the buildings. This is because as the tanks are placed at a greater height, the pressure of water will be large enough to force the water to reach the taps of the houses. Atmospheric pressure. We live on the earth and there is a lot of air around us. The layer of air surrounding our earth is called atmosphere. The air in our atmosphere extends up to a height of about 300 kilometers above the surface of the earth. Air has weight, so it creates pressure on the objects below. The pressure exerted by the air due to weight is known as atmospheric pressure. The atmospheric pressure on the Earth's surface at sea level is about 100 kilopascals, 100 kPa. If such an enormous amount of pressure is acting on us, why do we not feel it? This is because the pressure of the blood in the blood vessels and other fluids present in the body balance out the atmospheric pressure. Applications of air pressure. Drinking straw. We normally use a drinking straw to suck up fruit juice. When we suck air at the upper end of the straw with our mouth, the pressure of the air inside the straw is reduced. But the pressure acting on the surface of the fruit juice is equal to the atmospheric pressure. So, the greater atmospheric pressure acting on the surface of the fruit juice pushes the fruit juice up the straw into our mouth. Syringe. When the nozzle of a syringe is dipped in a liquid and its position is withdrawn, the pressure inside the syringe is lowered. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid up into the syringe. Rubber suction pad. Rubber suction pads are used on the walls to hang clothes and calendars. When moistened rubber suction pad is pressed against the wall, the air between the suction pad and the wall is forced out, reducing the pressure inside. The outer atmospheric pressure, being greater, pushes the suction pad firmly and it adheres to the surface of the wall.
Thank you.